Okay, so get this. Hubble has spotted something seriously wild around this young star FU Orionis. And it's making our sun look like, well, a cosmic ice cube.
It's true. This star is really pushing the boundaries of what we thought we knew about young
So
stars.
let's dive into exactly what Hubble found and why it's got everyone buzzing.
Well, it all starts with this disk of material swirling around FU Orionis.
Like a cosmic donut.
Yeah, you could think of it that way. And Hubble was able to measure the temperature of this disk.
Oh.
It clocked in at a mind-blowing 16,000 Kelvin.
16,000 Kelvin. I mean, wow. For context, the surface of our sun is only about 5,800 Kelvin. So this disk is nearly 3 times hotter than our sun. That's not just a small difference, right?
No, not at all. It's a massive difference. It's actually almost double what scientists had previously estimated.
Whoa. Okay, so this is just like a minor miscalculation. This is a huge discrepancy.
Yeah.
It's going to have some serious implications.
Definitely. It's forcing us to rethink our entire understanding of how these young star systems work.
Okay, so to really grasp the significance of this discovery, let's break down some basics. Remind us, what exactly is an accretion disk? And why is it so important for a young star like FU Orionis?
Sure. So when a star is born, it doesn't just poof into existence. It forms from a giant cloud of gas and dust. And after the star ignites, there's often some leftover material swirling around it. That's the accretion disk.
So it's like the leftover scraps from the star's formation.
Exactly. And these scraps aren't just trash, they're actually crucial for the star's growth. The star pulls in or accretes material from the disk, using it as fuel to bulk itself up.
So it's like a cosmic buffet for a growing star.
That's a great way to put it. And while most young stars go through this accretion process, FU Orionis is known for being a bit of a messy eater.
Messy how?
Well, it doesn't accrete material at a steady pace. It goes through these dramatic bursts in brightness as it pulls in huge chunks of material.
So instead of like a steady snack, it's more like FU Orionis is binging on this cosmic buffet.
Oh, that's a really good analogy. These outbursts are incredibly fascinating to observe because they give us clues about the complex dynamics happening between the star and its disk.
Speaking of clues, let's get back to Hubble's big discovery. Researchers were studying this disk, trying to understand its hotspots. What did they find that was so unexpected?
So they were looking at the ultraviolet light coming from the inner edge of the disk where the material is closest to the star. And what they saw was that this UV light was way brighter than anyone had predicted.
Okay, so the disk itself is already incredibly hot.
Mm.
But there's something happening at that inner edge where the disk meets the star that's generating even more heat and intense UV light. What could be causing that?
Well, the current thinking is that we're seeing evidence of a powerful shock wave.
A shock wave.
Yeah. As material from the disk spirals inward and slams onto the star's surface, it creates this massive shock wave.
So like a cosmic sonic boom, but with heat and light instead of sound?
Exactly. And this shock wave is thought to be the key to explaining those super high temperatures Hubble observed.
Wow. So we've got a ridiculously hot disk, a star with an insatiable appetite, and now a powerful shockwave. It's like a cosmic action movie unfolding right in front of us.
It really is. And this discovery isn't just a cool spectacle. It's forcing us to completely rethink our understanding of FU Orionis.
Probably about other young star systems, too.
You got it. This chaotic, energetic process might be more common than we initially thought. And it all has major consequences for any planets trying to form around FU Orionis.
Oh, yeah. That's right. We can't forget about the planets. Now, that's a story for next time because we're going to delve into what this all means for the possibility of planets surviving in this wild system.
It's a story you won't want to miss.
You bet. So stay tuned, folks, as we continue our deep dive into the fiery world of FU Orionis.
Okay, so that shockwave revelation, I mean, wow, it really makes you think about the sheer power and energy involved in these young star systems.
It really does, and it highlights how dynamic and chaotic this stage of stellar evolution can be. It's not just about a star forming. It's about a whole system forming planets, asteroids, all swirling around in this cosmic dance.
Exactly. And FU Orionis is giving us a front row seat to this incredible process, a process that's crucial for planet formation, but so difficult to observe.
Because it's so messy, right? It's like trying to study a toddler mid-tantrum.
That's a perfect analogy. These outbursts make it really hard to get a clear picture of what's happening within the disk.
So it's not just about the outbursts themselves, it's about the lasting impact they have on the disk and the planets forming within it.
Absolutely. One thing to consider is that as FU Orionis consumes all this material from the disk, it starts to create a gap or cavity in the inner regions.
So it's like eating a donut and creating that hole in the middle.
Exactly. And that gap can have a significant impact on the dynamics of the remaining material, potentially affecting the formation of planets further out.
It's like rearranging the furniture in a room. It changes the whole feel of the space.
Precisely. And then there's the sheer amount of material FU Orionis is consuming. It's estimated to be gobbling up material at a rate hundreds of times greater than our own sun did in its early years.
Hundreds of times. That's insane. I mean, talk about a hungry star.
It's an incredible amount, and this voracious appetite leads to those dramatic outbursts we've been talking about.
So the rapid consumption leads to instability, which causes the outbursts, which in turn shapes the disk and impacts the formation of planets. It's all connected.
It's a complex interplay of forces, and it challenges our traditional view of planet formation.
I used to picture it as this slow and steady process with planets gently coalescing over billions of years. But now I see it's much more dynamic and chaotic.
And it's happening on much faster timescales than we initially thought. These outbursts and accretion events can occur over periods of decades or even centuries.
Wow, that's incredibly fast in astronomical terms. So the environment around a young star like FU Orionis is constantly changing, presenting both challenges and opportunities for planet formation.
Absolutely. It's a delicate balance. And it raises a crucial question: can planets actually survive in this kind of environment?
Yeah, I mean, with all that intense heat, the outbursts, the shock waves, it seems like a pretty hostile place for a planet to try and form.
It's definitely a tough neighborhood. But the story isn't quite so simple. There are a few factors that might give these planets a fighting chance.
Okay, so what are these factors? What might determine whether a planet can actually make it around FU Orionis? Okay, so we're back and ready to tackle that big question. Can planets actually survive around a star as wild and chaotic as FU Orionis?
It's the million-dollar question, isn't it? I mean, we've talked about these intense outbursts, the shock waves, the crazy high temperatures. It doesn't exactly sound like a welcoming place for a planet to form.
Yeah, it sounds more like a cosmic obstacle course.
You could say that, but here's the thing. The story isn't quite so simple. There are actually a few factors that might give these planets a fighting chance.
Oh, really? Like what? I'm all ears.
Well, one crucial factor is timing. If these outbursts happen early on in a planet's formation, when it's still small and vulnerable, the chances of survival are pretty slim.
Makes sense. It's like a tiny seedling trying to survive a hurricane.
Exactly. But if a planet can manage to grow larger before those outbursts become too intense, its chances of making it through significantly increase.
So it's a race against time?
Yeah, you could say that. It's like a cosmic survival of the fittest. The bigger and stronger a planet can get before things get really wild, the better its chances of survival.
So size definitely matters in this scenario.
Absolutely. Larger, more massive planets have more gravitational strength to resist being pulled around or even flung out of the system during these outbursts.
So it's like having a stronger anchor to hold you steady during a storm.
That's a good way to think about it. But what about those planets that are forming closer in? We talked about how they're at risk of being fried or even spiraling into the star.
Yeah, this doesn't sound good. I mean, it's already a hot zone, and then you add those outbursts and shock waves. It's got to be a tough place to exist.
It definitely is. The closer a planet is to the star, the more intense the heat and the gravitational forces. It's like trying to live right next to an active volcano. Not exactly ideal.
Not at all. But is there any hope for these planets?
There might be. You see, there's this fascinating concept called migration, where planets can actually shift their orbits over time, moving closer or further from their star.
So a planet that forms in a danger zone might be able to move to a safer location.
Exactly. And what's even more intriguing is that these outbursts we've been talking about might actually play a role in triggering this migration.
So the same outbursts that threaten these planets might also be their saving grace.
It's a possibility. It's this really complex dance between destruction and creation, and we're still trying to figure out all the steps.
This is blowing my mind. It's like the universe has this amazing ability to both challenge and nurture these planets.
It really does. And FU Orionis is a perfect example of just how dynamic and unpredictable these systems can be.
This whole deep dive has really changed my perspective on planet formation. I used to think it was a pretty straightforward process, but now I realize it's more like a cosmic game of chance, with planets forming and evolving amidst all this chaos.
You got it. And that's what makes it so fascinating. We're constantly learning new things and challenging our assumptions.
Well, as we wrap up our exploration of FU Orionis, what's the one big takeaway you'd like our listeners to remember?
I think the biggest takeaway is that the universe is full of surprises. It's a constantly changing dynamic place. And even in the most chaotic environments, there's always a chance for something new and incredible to emerge.
Well said.
Yeah.
And that our understanding of the universe is always evolving. With each new discovery, we get a little closer to unraveling the mysteries of the cosmos.
And that's what makes this journey so exciting. There's always something new to discover, something new to learn.
Exactly. Well, listeners, that concludes our deep dive into the fiery world of FU Orionis. We hope you've enjoyed the ride.
And who knows what other amazing secrets are out there waiting to be uncovered.
So keep those questions coming, keep exploring, and never stop looking up at the stars.